Good evening, students. In our last class, we had done the identification of the elements of the matrix. Today, we would like to discuss about the types of matrix. Now, types of matrix means what? A matrix can be classified in so many ways, depending on their number of columns or number of rows. Also, we can classify them. For example, if the matrix is consisting of m number of columns and only one row, then the matrix is called row matrix. I can give you a simple example like this. For example, the matrix, suppose 1, 2, 3. The order of this matrix can be written in this way. That is one row and 3 columns. So 1 by 3, so it's a 1 by 3 matrix. Similarly, we can say that 1, 2, 3, 4, 5. It is also a row matrix. And here the row is 1 and column is what? 1, 2, 3, 4, 5. So order of this matrix is 1 into 5. So if a matrix is order is 1 into m, we can say, so if the matrix of the order 1 by m, this matrix is called row matrix. Understood? Next is column matrix. Column matrix. Now, what is column matrix? Again, like the row matrix, if the matrix is consisting of m number of rows and only one column, then that matrix is called column matrix. For example, I can write this way: 1, 2, 3. So this matrix order is supposed to be 3 into 1. 3 into 1 means it has 3 rows: row 1, row 2 and row 3, and column is only 1. So this is called column matrix. Or we can say also in this way: 1, 2, 3, 4, 5. So this matrix is consisting of one row but 5 columns. 5 rows and 1 column. Column should be always written in the second place and row should be always written in the first place. So this is a column matrix. Second example. So in this way, you can understand the column matrix. Next is zero matrix or null matrix. Now, before writing zero matrix, what is zero matrix? Zero matrix, when all the elements of a matrix, is 0. Now, if I say 0, 0, 0, 0, it is a 2 by 2. Then I will write this in this way: zero matrix. Zero matrix also can be a rectangular matrix also. That is, it's a rectangular type matrix: 0, 0, 0, 0, 0, 0. It is, this type of matrix is also called rectangular matrix. But when all the elements of a rectangular matrix is 0, in this way, for example, it is a 2 by 3 null matrix. So null matrix can be like this. Now, after that, we have to learn square matrix. What is square matrix? Square matrix, what is square matrix? When the number of rows and the number of columns of a matrix are same. When the number of rows and number of columns of the matrix is same or equal, we can say that matrix is a square matrix. For example, if I want to write a 2 by 2 square matrix, I should write in this way: say A11, A12, A21, A22. It's an algebraical example of square matrix. And if I want to write this way also, 2, 3, 3, 1, it is a 2 by 2 square matrix. It's a 2 by 2 square matrix. This is 1, 2, 3, 4, 5, 6, say 7, 8, 9. This is a square matrix of 3 by 3. So 3 by 3 square matrix. It is a 2 by 2 square matrix. As far as your class 12 syllabus, generally we shall concentrate in the square matrix in long run, and particularly 2 by 2 and 3 by 3. This type of square matrix are very important in class 12 syllabus, both for cbse and ISC. So once we understand square matrix, then we have to understand the concept of diagonals. See, along these diagonals, this diagonal is very, very important in the square matrix. This diagonal for any square matrix, is very, very, very important. This diagonal is called principal diagonal or primary diagonals. So primary diagonal, and based on the primary diagonals, we will also classify different types of matrix that we have to also understand. How we define those things? For example, based on the principal diagonal, we can define diagonal matrix in this way. So diagonal matrix. What's the number? 5. Diagonal matrix. What is diagonal matrix? The diagonal matrix is the matrix when the elements of the primary diagonals are non-zero, and other than the primary diagonals, all the other elements must be zero. That is, if I write this 2, 0, 0, 5, so 0, 5, 0, 0, 0, 3. It is a square matrix. Definitely, a diagonal matrix has to be a square matrix, and these elements along the principal diagonals or primary diagonals, these elements are non-zero, and the other element means what? Other element means zero, these elements, that is above the primary diagonals or below the diagonals, all the elements should be zero. By the way, one important concept I should say, along these primary diagonals, if I want to understand what are the elements are above the diagonals. Above the diagonals, if I want to say that these elements here, the number of rows always is less than number of columns. Here, if you see, this is called what? A12. Here 1 is less than 2. Here it is A13. 1 is less than 3. Here it is A23. So all the elements above the primary diagonals are whose number of rows always is less than number of columns. Similarly, below this is very important concept. So these elements we can understand in this way: Aij's when I is less than j. Similarly, below these primary diagonals, these elements, here it is Aij when I is more than j. Here number of rows is more than number of columns. So Aij when Aij is equal to 0 when I less than j, and Aij is also 0 when I is more than j, but Aij is non-zero. So how can I define a diagonal matrix? A diagonal matrix can be defined technically in this way: when Aij is not equal to 0, when I is equal to j, Aij is equal to 0 when I is not equal to j. I is not equal to j, Aij is 0, and Aij is not equal to 0 when I is equal to j. Then the matrix we can say as diagonal matrix. We can define a diagonal matrix in this way, or we can understand in this way: diag A1, A2, A3. In this way also we can express a diagonal matrix. In some question paper or in joint entrance also you can see this type of language. You have to understand if it is written diag A1, A2, A3, then you have to understand it's a 3 by 3 diagonal matrix. So in that case you can express this matrix in this way, that is A1 0 0 0 A2 0 0 0 A3. So in this way you can understand this language diagonal A1, A2, A3. In fact, in the assignment also you can get this type of questions that add diag A1, A2, 3 plus diag B1, B2, B3. So you can understand that you are asked to add two diagonal matrix. So once we understand that what is a diagonal matrix, next we have to understand scalar matrix. Basically these are all same, but conceptually they are something different. Now what is a scalar matrix? The scalar matrix are the diagonal matrix when all the diagonal elements along the primary diagonals must be same. That is scalar matrix. Scalar matrix. Here I can give one example. For example, 2 0 0 0 2 0 0 0 2. This is called a diagonal matrix when all the primary elements of this diagonal must be same. Then it is called scalar matrix. So basically from after learning diagonal matrix and scalar matrix, next we have to learn what is the unit matrix. That is actually our objective to come. So a unit matrix is also a square matrix and also a diagonal matrix and also a scalar matrix. So unit matrix or we can say this as identity matrix. Identity matrix. The unit matrix or identity matrix can be defined when these primary diagonals are 1. What happens when a scalar matrix, the diagonal elements are 1, all are 1, then that scalar matrix you can say identity matrix. That is 1 0 0 0 1 0 0 0 1. This is a I3, that is 3 by 3 square, 3 by 3 identity matrix. Similarly, a 2 by 2 identity matrix can be written as in this way 1 0 0 1. These two are very very important. That's why I have defined both these type of identity matrix. I hope you have understood. The concept is clear. What is next time we will also discuss why we define this as identity matrix. This is a very conceptual name, identity matrix. We have to understand it conceptually why the name of this matrix is identity. Once we understand the product of the matrix, again we will come back and we will discuss about the significance of this name. Next is upper triangular matrix. So what is upper triangular matrix? Again, as I said, that we are classifying this matrix based on the primary diagonals. When the when the elements above the primary diagonals are non-zero, or you should say the elements below the primary diagonals are 0, then those matrix is called upper triangular matrix. That is above the primary diagonals, all the elements are non-zero. That's why its name is upper triangular matrix. All the upper elements are non-zero, but all the below elements of the primary diagonals are 0. That means if I want to give an example of upper triangular matrix, this is your 6, 7, 8 upper triangular matrix. That is 1, 2, 3, 4, 5, 6. and here I will write all these elements 0. That means it's a 3 by 3 upper triangular matrix where these elements are 0. These elements are 0 means what? These elements are 0 means the matrix when Aij is equal to 0 when I is more than j. This is you have to understand. I is more than j, and Aij is equal to is not equal to 0 when I is equal to j, and Aij is not equal to 0 when I is less. This is a technical definition of the upper triangular matrix. Next is lower triangular matrix. If we understand the upper triangular matrix, we also understand the lower triangular matrix. What is lower triangular matrix? The lower triangular matrix is same thing when all the elements below the diagonals are non-zero and above the diagonals, along with diagonals, all are zero. Then you can say lower triangular matrix. Example: if I say 1, 0, 0, say 4, 0, 6. With these primary diagonals, all the below elements are non-zero. Say 3, 5, 2. This is a lower triangular matrix. And technical definition of the lower triangular matrix, how can we understand? We can understand it if I say that Aij, here as I told you, the above the element I is always less than j. So Aij should be equal to 0 if I is less than j. Aij is not equal to 0 if it is always like this, and Aij is not equal to 0 if I is more than j. This is the definition of lower triangular matrix. Now once we understand the concept of this matrix, the last case which is generally coming in joint also, and is tracing of matrix or trace of matrix. What is the generally in 2 mark question? We can also give you this trace of matrix. Most of you forget the concept of trace of matrix. So what is trace of matrix? The last concept, trace of matrix. Trace of matrix. Trace of matrix. Generally, we define as find the TR of A. TR of A. The matrix is a TR of A. That is sum of the diagonals, sum of the elements of the primary diagonals is called the trace of the matrix. That is, if I say A1, the A2, A11, A12, A13, A21, A22, A23, A31, A32, A33. Here TR of A, I will write A11 plus A22 plus A33. This is called tracing of matrix. Tracing. That is, TR of A is nothing but sigma Aij when I is equal to j. This is very important. Tracing of matrix is to come or can also come in joint entrance. This is, and last but the least is submatrix. This is 11 classification, submatrix. Submatrix is what? What is submatrix? Submatrix means whenever we are deleting any one row or any column of a mother matrix and get another type of matrix, or if we delete both rows and columns, then also we can get the submatrix. For example, if the matrix is equal to suppose 1, 2, 3, 3, 4, 5, 6, 7, 8, then if I delete this one, I can get this rectangular matrix. So this is a submatrix which is we are getting from the given matrix. One important concept of submatrix also can be said minor factor of this. So if I want to know, suppose if I want to delete the first row and first column, then you can get this one. This is called 4, 5, 7, 8. This is basically later on we learn the cofactor, minor factor of A11. 1 का जो minor factor, that is 4, 5, 7, 8. Very, very important concept. In this way, we can get total 9 minor factor. And those 9 minor factor matrix is very important. And that's why we are learning submatrix. Understand what is submatrix? If we delete any one row or any one column, for example, if I, from here also, if I delete this column, I can get 5, 8. This is also an example of submatrix. And it's also a column matrix, right? So this is the submatrix, and last but the least is equality of matrix. Now, equality of matrix means what? We can equalize, you can compare the two matrices like this. Suppose if I say a matrix is x, y, 2, 3, another matrix if I say 5, 6, 2, 3, that is, here you see, you can compare the row 2 for the first matrix and row 2 for the second matrix, they are same. So if we compare these two matrices, we can say that x is equal to 5 and y is equal to 6. This is actually we are getting the equality of matrix. This also we have learned in class 10 also. So I don't want to interfere more, just to reconnect you. As I told you, from here the question also can come. You may be given that solve x and y like this, x plus y 2, 3, and you are given say x minus 1, 1. This is 5, 2, 3. You may be asked that solve x and y. So in that case, you can, in class 10, you have to equalize. You should say that x minus 1 is equal to 1. You should say x plus y is equal to 5. Then solve these two equations and you can get x and y. So this is all about the types of matrix. So today we have learned the types of matrix. So next we will learn the operation of matrix, that I will send my video in my next class. Thank you very much. Today only you have learned types of matrix. सबसे important है, don't forget the trace of matrix, that is sum of the diagonal of the matrix of a square matrix is called the trace of matrix. Understand? We have also discussed about the unit matrix, that is also very important. That is what? That is when the scalar matrix the diagonals are 1. So based on the diagonal elements, we have basically classified all these square matrix, and those are very important concepts. Thank you very much, and listen my video regularly and give me feedback on how much you have understood. Thank you.